Miss Ethel to lead us in our opening prayer. Miss Ethel.
Let us pray. Heavenly Lord, thank you for this wonderful day. As we start our class this morning, may you guide us and give us knowledge so that we can understand the lessons. This is pray us in Jesus' we pray. Amen.
Thank you, Miss Ethel. Okay, so this morning I'll be discussing, talking to you our last lesson, as I mentioned earlier, in mathematics in the modern world. So this is all about modular arithmetic. Huh? This is all about modular arithmetic. I think I already uh, uploaded this presentation in our group chat. So I hope that you are reading that one in advance. Afterwards, I also exercises are posted here, but I will send you a quiz for our Google link after my discussion, rather, and the other activities that will be submitted tomorrow. Okay, so we'll be define first what is modulo based on the concept of modular arithmetic. Two integers a and b are said to be congruent modulo n, where n is a natural number if the ratio of the difference of two numbers a and b over n is an integer. So it is resulted to an integer quotient. It could be a negative or positive, basta integers yan. No? So in this case, we write this form a is equivalent to b modulo n. And the number n here after the word mod here or modulo is the modulus. And the statement A, this one is called the congruence po ito, no? So A is congruent to B modulo N. So how could we know that this one is a congruent statement or congruence statement? If the ratio, A minus B over N is an integer. Okay, so let us cite an example. Determine whether a congruence is true. So this would be your A, this would be your A, this is your B, and this is your N. So by using the idea presented in the definitions, so that is simply 29 minus 8 over 3. No? So A minus B over N. So you'll have 21 over 3, and 21 divided by 3 is 7. And again, 7 is an integer. So that's why this statement is a congruence statement. 29 is congruent to 8 modulo 3. Okay, for letter B, you have 15 if that is congruent to 4 modulo 6. So again, using the idea, and the definition, so 15 minus 4 over 6, a minus b over n, that is equal to 11 over 6, no? 11 over 6. And 11 over 6 is not an integer, so that will resulted to a fractional number. So that's why this one is not a congruence statement. It is a false, or it is not a true congruence. Okay, so what you need to do based on the modulo n is simply you have to consider the ratio of these numbers here, two numbers, the difference of a minus b over n, and if that resulted to an integer, then we can say that this statement is congruence. Okay, another example here. So a day of the week, example 2, July 4, 2010 was a Sunday. What day of the week is July 4, 2015? So again, if you have no background in modular arithmetic, so what you need to do is simply to see your calendar apps to find out what would be July 4, 2015. But if you have the knowledge in modular arithmetic, so we can just simply solve it arithmetically, no? So of course there are 5 years between the two dates, no? The July 4, 2010 and July 4, 2015. And each year has 365 days, no? 365 days except 2012, which has one extra day because it is a leap year. So how could we know that that year is a leap year? of course, if there's one additional day in the month of February. So in other words, like February 29. And leap year only happens every 4 years. So yan, every 4 years. That will not happen every year, but it will only happen every 4 years. So if that is 2012 is a leap year, so 2016 will be the next leap year, then 2020, okay, then 2024, 2028, so on and so forth. So in this case, the total number of days between the two dates is 5 times 365. So in a year, there are what, 365 days. So 5 times 365 plus 1, you'll have 1,826. And 1,826 divided by 7, you might say, sir, anong i-divide man nato sa 7? Because we are talking here a day of the week arithmetic. In a week, there are 7 days. Okay? In a week, there are 7 days. So, maura na siya. When you talk about modular arithmetic, whatever our modulus, after it reaches that modulus end, it will go back again to the starting point. So once we reach the 7th day, so we'll go back again to first day, second day, third, fourth, fifth, sixth, seventh, then eighth, first na po, second, third. So walay 8, 9, 10, di ba? So that's how we understood that. So sa counting pa nato, every 10, no? Ang counting nato. But computer, ang ilang counting is 0101 lang. Binary lang yung operations na ginagamit nila. That's why when you ask, no, to solve even a large number using computer software or Excel, shall we say, the Excel will directly give you the answer because of the the style, no, of their computations or arithmetic that will only use two numbers, 010101. Okay, so in this case, any multiple of 7 days past a given day will be the same day of the week. So the week of so the day of the week, 1,826 days after July 4, 2010, will be the same as the day 6 after July 4, 2010. Why? Because the main concern in modular arithmetic is the remainder. At the end of our class today or this morning, just take note that the answer is the remainder. Take note, ha? The answer is the remainder. So since ang atong remainder diri is 6, so in other words, ang July 4, 2015 is just same to 6 days after July 4 in 2010. Okay, so in that case, July 4, 2015 will be a Saturday. If we have this numbering, no, that 1 would be Monday, 2 would be Tuesday, 3 would be Wednesday, 4 would be Thursday, 5 would be Friday, 6 would be Saturday, and 7 would be Sunday. So in that case, the day of the week, no, the day that July 4, 2015 falls will be on Saturday. Okay, so of course, since we are talking arithmetic here, we'll also have what we call operations, no? Arithmetic operations, similar to what we have learned or understood about the usual arithmetic that we have. So arithmetic modulo n, where n is a natural number, uses a variation of the standard rules of arithmetic we have used before. So perform the arithmetic operations and then divide by the given modulus. So the answer is the remainder. So take note, the answer is the remainder. Thus, the result of an arithmetic operations modulo n is always a whole number, less than n. So obviously the result, okay, or the result of the arithmetic operations modulo n is always a whole number less than n. When you say whole number, so in that case, uh, 0 is included, it could be, but it is less than n. There's no such thing as negative number because we are talking about whole number. Set of whole number included yung 0, 1, 2, 3 to positive integer. Okay? So let us cite example 3. Let us start with addition modulo n. So we say you ask to evaluate 23 plus 38 modulo 12. So your n here, the modulus is 12. So first you have to add, no? These two addends here, 23 plus 38. So 23 plus 38 is equal to 61. Then you divide that by 12, the n, the modulus. And again, the answer is the remainder. Of course, do not attempt to use cell phone or calculator and you will get the decimal part after point. Of course, that's not the answer. So what you need to do here is you do it manually. based on what you have learned about the long divisions in your elementary years, no? Yung basic na pag-compute natin sa division using long division. So 61 divided by 12, that is 5. And 5 times 12 is 60. You get the difference, 61 minus 60, that's why the remainder is 1. And the answer of this is 1, not 5. Okay, take note, the answer is the remainder. Okay, for subtraction modulo n, so evaluate each of the following. For letter A, you have 33 minus 16 modulo 6. So you subtract this one first, 33 minus 16, that is equal to 17. And of course, in this case, the result is positive. Divide the difference, no? You divide the difference by the modulo 6. So 17 divided by 6, again, the answer is the remainder. So 17 divided by 6, that is equal to 2. 2 times 6 is 12. So 17 minus 12, that's why the remainder is 5. So the answer for letter A is 5. For letter B, basically for letter B, you may notice that it will end up with a negative value, no? It will end up with a negative value. So if you get 14 minus 27, ito, you will get negative negative 13, di ba? 14 minus 27, that is negative 13. What you need to do is you add that to the modulus until you will get a whole number less than n. So 14 minus 27 is negative 13. You add that to 5, you will get pila? Negative
Negative 8, sir.
negative 8. Then you plus that again to the modulus. That is, you will get negative 3.
3.
Okay? Then you add that again to positive 5, you will get positive 2. Diba ang 2 is less than 5, less than the modulo? And it is within 0 to 4. So in that case, for letter B, the answer is 2. So if you get a negative number in subtraction modulo n, so you do not attempt to directly divide that by 5 because you will again get a negative remainder. And again, as I mentioned earlier, that once you divide those difference or sum modulo n, the answer must be a whole number less than n. Okay? Or another way of doing that class is you have negative 13, negative 13 plus x. You apply the idea of congruence, over our n here is 5. That is will resulted to an integer, no? That will resulted to an integer. So try to no, this is not plus minus 13 minus x over 5. Find a value of x that will resulted when you say negative 13 minus that number divided by 5, that will equal to an integer. So in this case, so if we will substitute 2 here, so negative 13 minus 2, you will get negative 15, and negative 15 divided by 5 is equal to negative 3, and negative 3 is an integer. So in that case, 2 here is the value of x, and that is the answer for that problem. Okay? Okay, so let us proceed to example 5, somehow related to letter B. Okay, this regarding EM or PM. If it is 5 o'clock now, what time was it 57 hours ago? So since we are using the clock arithmetic has modulo of 12 arithmetic po yan. Why? Because once we reach at 12 noon, we go back again to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Once we reach 12, we'll go back again to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So unlike sa military clock, that 12, there is 13, 14, 15 until 24. Then once we reach 24, we'll go back again to 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. Okay? So this is a clock arithmetic. Okay? So the time can be determined by calculating, no? You have here 5 minus 57. Why it is minus 57? Because what time was it 57 hours ago? 57 hours ago. Unless it says here, was it 57 hours after? Ago kasi. So, Of course, you can do it manually using your clock there, no, or your watch. You just count backward, no, 57. Count 57 backward, starting from 5. Then you will get the result. Okay, but again, do not do that one anymore. No, once you have the idea of modular arithmetic, so you can just have 5 minus 57, that is negative 52, and it is a negative number. So what we need to do is find a whole number x less than the modulus 12. So ang value sa x ani is within lang gid from 0 to 11. So in this case, you can use the modulo n for definitions there. So you can have negative 52 minus x, no, over 12. That is, you factor out negative 1. So negative of 52 plus x over 12. Find a value of x that will result to this one to an integer. Okay? So evaluating the expressions for a whole number values of x less than 12, so we have x is equal to 8. So when you add 8 to 52, you will get 60. So nanay negative daan sa gawas, no? So negative 60 divided by 12, that is equal to negative 5. And it is an integer. So kay integer man siya, so that's why the value of x is equal to 8. So in other words, if it is 5 o'clock now, kung alas 8 karon sa buntag, 57 hours ago or 57 hours ago, it was 8 o'clock. Okay, disregarding, no, disregarding either it's EM or PM. Okay, so of course you can also solve the other way around by simply adding negative 52 by the modulus until, no, you will get a difference that is within 0 to 11. So you'll start with negative 52, negative 52 plus 8, or plus 12 rather, negative 52 plus 12, that is negative 40, negative 40 plus 12, that is negative 28, negative 28 plus 12, that is negative uh, 16, negative 16 plus 12, that is negative 6, okay, burag sayop ko. Okay, negative 52 plus 12, that is negative 40, negative 40 plus 12, that is negative 28, negative 28 plus 12, that is negative 16, negative 16 plus 12, that is negative 4, negative 4 plus 12, that is positive 8. So that's why the value of x is equal to 8. So you can also work in that manner. But somehow, baka mahurot imong oras during the examinations when I give you the value, say negative 100 or negative 200, and the modulus is 5 or 4. So, madugay kag plus 4 plus 4 plus 4, di ba? So what you need to do is, you will do in this manner, no? Or in this form. Okay, any questions for this example? Okay lang? Hello? Hmm. So you will have after, so that is 5 plus 57 po ka. 5 plus na po mong gamitan. Then the same procedure, so 5 plus 57, pila man ng 5 plus 57, that is 62, di ba? So mas dali na lang siya. Dili na ka magingani. Kay positive man ang value, no? So 62 divided by 12 na dayon ka. So what is 62 divided by 12? Whatever the remainder, mo ito yung answer nimo. So pila man ang 62 divided by 12? Isa may na ay ano niyo diya, maka-compute niyo ana. Be, kung ballpen dire. O lapis. 62
Five.
62 divided 12, 5 times 12 is 60.
Five.
Dili ang answer ang quotient. Ang answer is the remainder. So, ang the remainder is, pila yung remainder? 2, di ba? 62 divided by 12. Di ba ang remainder is 2? So, in other words, if it is 5 o'clock now, so 57 hours after will be 2 o'clock. Okay? Disregarding EM or PM na siya, ha? So, after 57 hours, if it is 5 o'clock at this moment, So 57 hours after will be 2 o'clock. So of course, the answer is the remainder. Don't forget that. Ha? The answer is the remainder. Remainder. Okay? Nasolve na ang imo ang question, Mr. Abdul. Okay lang? Okay, thank you. Okay, then we have also multiplication modulo n. So in this case, you have to evaluate 15 times 23 modulo 11. So in this case, you have to multiply first, no? So 15, no? 15 times 23, then whatever the product, you divide that by the modulus. So in this case, our modulus is 11. So 15 times 23 is 345. 345 divided by 11, that is equal to 31, and the remainder is 4. So in this case, the answer is 4. Again, take note, don't forget, no? At least, no? Hindi mo malimutan ito that the answer is the remainder. Okay, then we have also here, okay, at na lang yung bayaan na. Okay. We have also additive and multiplicative inverse in modular arithmetic. What we have learned in the usual arithmetic that we have, then when we say additive inverse, the sum, no, of these two numbers is equal to 0. So for example, you are given the number 8 and you ask to find what is the additive inverse of 8. So obviously the additive inverse of 8 is negative 8. Why? Because if you subtract 8 plus negative 8 is equal to 0. So 8 is the additive inverse of negative 8 and vice versa. So ganun yan. So kana gani nga number, pag add nimo ana nga number and their sum is equal to 0, then the two numbers are said to be inverse with each other. Okay? So in modular arithmetic, the way we understood that is dapat if you get the sum of those two numbers, you divide that by the modulus, and if the remainder is 0, then that two numbers are additive inverse with each other in that particular modulo n arithmetic. Okay, for example, find the additive inverse of 7 in modulo 16 arithmetic. So obviously, what number that you need to add to 7 in order for you to get the sum of 16? Diba? 9. Kaya 7 plus 9 is equal to 16. Diba ang yang sum is equal to the modulus? So obviously, diba, kung mag-divide tag number, nga pareha ang dividend and the divisor, then the result is equal to 1, remainder 0. So in that case, the additive inverse of 7 is 9 in modulo 16 arithmetic. Of course, dili po na siya always nga 9. Sa kung modulo 15 arithmetic, so dili na po 9 ang additive inverse sa 7, kung dili 8. Kay pila maimong i-add sa 7 para mahimong 15, di ba 8? So mo to siya ang modulo, mo to siya ang additive inverse. Okay? So, why we have that idea? Kasi 7 plus 9 is 16. And 16 divided by 16 has a remainder equal to 0. So, any two numbers that when you add and you divide that by the modulus, and if the remainder is 0, then those two numbers nga gi-add nimo are additive inverse with each other. Okay, how about the multiplicative inverse? The usual idea that we have, no, sa arithmetic nga atong nabaw-an before, that the two numbers are said to be multiplicative inverse if their product is equal to 1, di ba? So for example, the product of 2 and 1/2 is 1. Okay, 2 times 1/2 is equal to 1. So 2 is the multiplicative inverse of 1/2 and 1/2 is the multiplicative inverse of 2. Okay, that's the usual idea that we have learned before in arithmetic operations. So how about in modular arithmetic? So the idea still will be looking on the remainder. If you get the product of these two numbers, divide that by the modulus, and if the remainder is 1, then the two numbers are said to be multiplicative inverse. Okay, so you are given a number, and find a number, you multiply that by the given number, then you divide that by the modulus, and if the remainder is 1, then those two numbers are said to be multiplicative inverse. So for example, in this case, you'll have to consider this form, no? A of x or A times x is congruent to 1 modulo m. So take note, kaning 1 diri mo na atong remainder. That b ha, that integer b. Mo na atong remainder in the congruence form. Okay? So you have to find x. This a is given. You don't worry about that. So ikaw yung maghanap ng a, or given yung a sa problem. Ito yung hahanapin mo na x, any number, any integer, you multiply that to a, okay? And if their product, yung product nitong dalawa na to, i-divide mo sa m, sa modulus, given yan. And if the remainder is 1, then these two numbers, a and x, are said to be multiplicative inverse. Okay, example. Find the multiplicative inverse of 2 in modulo 7 arithmetic. So obviously, in modulo 7 arithmetic, you have to find a whole number n, no, a whole number x that is less than n, less than the modulus. So it could have 0, you could have 0 to 6, diba? So in this case, maybe we can start at 1. So understood naman na 0 divided by 7. Of course, the remainder of that is 0, no? So you don't need to do that one anymore. So you'll start at x is equal to 1. So you multiply 1 by 2 kasi you substitute x by 1. So 2 times 1 is 2. You divide that by 7. 2 divided by 7, the remainder is not equal to 1. Okay? 2 divided by 7, the remainder is not equal to 1, but it is equal to 2. Okay? Correct ba? 2 ba? Ang 2 divided by 7, ang remainder is 2. So any value sa x less than the modulo, so that would be any product rather, no, after you multiply that by 2, if that is less than the modulus, then that's always the remainder. Okay? For x is equal to 2, so 2 times 2 is again 4, which is less than the modulus. So understood, the remainder is 4, not equal to 1. 2 times 3 is 6, and again 6 is less than the modulus, no, less than 7. So again, the remainder is not equal to 1. So how about when you have x is equal to 4? X is equal to 4. So 2 times 4 is 8. 8 divided by 7, no? 8 divided by 7 is equal to having a remainder of 1. So in this case, in modulo 7 arithmetic, the multiplicative inverse of 2 is 4. Any questions? So kanusagan na ito may bawaan nga kana siya multiplicative inverse ang given nga number of that modulo n arithmetic if the remainder is equal to is equal to 1. Okay? So just find any number x. You multiply that to the given number a, and you divide that by the modulus. And if the remainder is equal to 1, then those two numbers are said to be multiplicative inverse. Okay, so let us now proceed to the applications of modular arithmetic. Now, there are 4, ISBN and UPC, credit card, and the last one here is about cryptology. Okay, ang ISBN and UPC are very important as an identifier, no? Especially when ISBN can be found at the back portion of any book, no? Books. Then UPC, this is also known as the product code or the barcode that can be seen also at the back portion of any products, no? It could be a junk food, beverages, no? A cola, so on and so forth. Okay, let us start with ISBN. The first 3 digits of the ISBN are 978. Okay, when you have your book there at your hand or wherever you are, no, kung naamoy libro diha, ang awa at the back portion, na ISBN number diha, and that will start at 978. In the next digit indicates the country in which the publisher is incorporated. No? So 0 and sometimes 1 for books written in English. The next 2 to 7 digits indicates the publisher. No? So publisher na siya nga number, next 2 to 7 digit. And the next group of digits indicates the title of the book. No? The title of the book and the last digit, the 13th one, there are 13, standard po yan sa ISBN, 13 digits na siya. You try to count the ISBN number that you can see, no, at the back portion of your book. That is known as the check digit, the 13th digit, no, ang pinaka-last nga number. If we label the first digit of ISBN as D1, D2, so on and so forth until D sub 13, then the check digit is chosen to satisfy the following congruence. Okay, and this is the formula, no? This is the This is the formula for the check digit. Okay? So you have here d sub 13 is equal to 10 minus, you have this open parenthesis, d sub 1 plus 3 times d sub 2 plus d sub 3 plus 3 times d sub 4. So you may notice here that every even place number, no, the second, the fourth, the sixth, the eighth, the 10th, and the 11th, the 12 places, multiplied it by 3. Okay? Kasi coming from the idea that the first 3 digit of the ISBN is composed of 3 number, no? 9, 7, 8. First 3 digit yan. Okay? And you have to find first the sum of these, no, within the parentheses, then you divide that by 10. And whatever the remainder, you subtract that from 10. Okay? And the 13 digit, no, the d sub 13, if it is equal to 10, then the check digit is 0. Okay? Do not include 10. Okay? Do not include 1, but only include 0. So, kung ang na-answer gani mo sa 13 digit is 10, then you only get 0, not 10. Okay? So, this is the formula for ISBN check digit. So, how could I know, sir, that the ISBN is valid or not? Just check the last digit using this formula, no? Okay, in order for you to check the last digit, then you have to use this formula. So if the last digit, the 13 digit, is equal, no, whatever the value here is equal to the last 13 digit in your ISBN book, then that is a valid ISBN. That means that book is published by a legal publisher, no? Legal publisher. Okay? So for example, determine the ISBN check digit for the book, The Equation That Couldn't Be Solved by Mario Livio. The first 12 digits of the ISBN are given, 978-0-7432-5820-question mark. So what you need to do is find the 13 digit. Okay? So to do that, using the formula, that is d sub 13 is congruent to 10. So this is why we say, anong na may 10, sir? Because we are talking the set of digits, na ba? Ang set of digits composes only of 10 numbers. That is from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Unang natay 10. Constant na siya, ha? 10 minus. Then using the formula 9, this is the d sub 1 plus 3 times the d sub 2, 7. Then plus so on and so forth. What you need to do is you have to find the sum this, no, inside the bracket, and that is equal to 97. Okay? Please do not solve it 10 minus 97 then modulo 10. No. You have to solve this one first. Kana siya. Kuhaon sa nimo ang remainder, ana, ha? So, 97 modulo 10. 97 divided by 10. That's how you do that. So, 97 divided by 10, the remainder is 7. So, that's why 10 minus 7 is equal to 3. So the check digit is 3. So the number that must be added after 0 is 3 in order that we have the valid ISBN. The valid ISBN. Any questions? Hello?
And so forth.
No, sir.
Okay. So let us proceed. Okay? So we have also what we call UPC or Universal Product Code. The UPC is a 12-digit number, no? 12-digit number. Unlike sa ISBN, that's at least 13-digit. But in this case, you only have 12-digit number. Somehow, we're not using 12-digit number in our barcoding sa produkto sa Pilipinas, no? Usually 13, no? 13 ang atong product code, no? Yung barcode na makikita niyo doon sa back portion ng mga pagkain, ng mga soft drinks or whatever, no? That satisfies a congruent equations that is similar to the one of the ISBNs. So again, the last digit is the check digit yapon na siya, class. So again, if we label the 12 digit, we can have D1, D2 until D sub 12. And what we need to find here is we have to check if that is a valid UPC or not by using this UPC check digit formula, no? So you have here D sub 12 is equal to 10 minus the quantity, parenthesis 3, D sub 1 plus D2 plus 3, D sub 3 plus so on and so forth. So you may notice here that ang odd number place na po ang gitimes og 3 ha, gitimes og 3. So don't forget that. So after that, you already multiply that by 3 yung mga number na doon sa odd number places, odd number places, then you get the sum, then modulo 10. Okay, if again the 12 digit is equal to 10, then the check digit is 0. Okay, so let us cite an example. Find the check digit for the DVD release of the film Alice in Wonderland. The first 11 digits are, okay, you have this, and what you need to find is the 12 digit. So using the UPC check digit formula, so you have 10. So this is again based on the set of digits that there are only 10 numbers minus, okay, this quantity. You multiply this 3 times 7. So you add, no, 21 plus 8 plus 20 plus 18 plus 9 plus 9 plus 6 plus 21 plus 9 plus 21 plus 9 plus 24. Whatever the sum, that is equal to 155 modulo 10. Dili 10 minus 55 ha. Unahon sa nimo o kuha ang remainder ani. So 155 divided by 10. 155 divided by 10 is 5. Then you subtract that from 10. So 10 minus 5 is equal to 5. So the check digit here is equal to 5. Okay, any questions?
No.
Okay. So let us proceed to credit card numbers. Of course, another application of modular arithmetic class is to determine if that credit card number is valid or not. And this idea is very important, no? Very useful in any e-commerce platform or any e-commerce platform like Lazada and Shopee, no? Because some of their buyers will transact using their credit card or debit card. And that's why these mga e-commerce platform are using the idea of modular arithmetic based on the loan algorithm. Okay? Loan algorithm po yung ginamit nila. Usually, there are 4 different kinds of card issuers. But in the Philippines, the very common are MasterCard and Visa. No? MasterCards have a prefixed first two numbers that's from 51 to 55, and the number of digits is 16. Visa, you have here 4, will start at 4, regardless na what would be the next digit after 4. And the number of digit varies, that is from 13 to 13 or 16 rather. Then you also have American Express and Discover, that's somehow not common in our country. No? Okay, so how the loan algorithm works in identifying if the given credit card number is valid or not. So the loan algorithm used to determine whether a credit card number is valid is calculated as follows. So first, beginning with the next to last digit. The last digit is the check digit, and reading from right to left. That is from right, no, from here to left, from right to left. Double every other digit. Okay, this is the next to the last digit. Then you double every other digit, no? So you double the 9, the 1, the 3, the 1, the 8, the 3, the 5, or those highlighted in red. If a digit becomes a two-digit numbers after being doubled, treat the number as two individual digits. Okay? Now, you find the sum of the new list of digits. You divide that by 10. And if the remainder is equal to 0, then that is a valid credit card number. Okay? So in our example 12, determine a valid credit card number. Determine whether 5, 2, 3, 4, so on and so forth is a valid credit card number. Okay? So yung highlighted in red will be doubled. So next, double each of the highlighted digits, na double na siya lahat, di ba? Then, in that case, add all digits. Ang 1/8, you treat this as an individual digit. So, you have 8 plus 8 plus 1 plus 2 plus 2 plus 0 plus 2 plus 4 plus 6 plus 3 plus 2 plus 2 plus 6 plus 1 plus 4 plus 6 plus 2 plus 0 plus 1. And the sum is equal to 60. You divide 60 by 10. So 60 divided by 10, you will get a remainder equal to 0. So ang remainder kay 0 man, so this is a valid credit card number. Any questions for credit card numbers? Hello?
Sir.
Yes. Any
Wala,
question?
sir.
Okay lang?
Yes, sir.
Okay, okay. So obviously, you will perform this one afterwards na lang ha, and these exercises. You submit this one tomorrow. Okay? So if none, let us proceed. There are 9 slides remaining na lang ha, before we'll end our class this morning. Okay, if mag-stop ni siya galit, kay ang Google Meet up to 45 minutes lang, then we'll go back ha, if in case ipanako ni Mahaman. Okay lang? Pila na lang ka ang time ani? Hello? Okay, napay time, no? Okay, any questions? If none, I'll proceed na to cryptology. Okay lang?
Yes, sir.
Yes, sir.
Okay. Cryptology class is again another applications of modular arithmetic, and this is somehow very important for those archaeologists or those mga treasure hunters that, of course, they want to read some code, no? Yung mga code that somehow mga secret codes, and they are also having to master this technique in order for them to really know what would be the password or the what that sacred code is all about. Okay, so that is the study of making and breaking secret codes. That is what we call cryptology. There is also what we call plain text, that is a message before it is coded, no? So the line, she walks in beauty like the night, when you say plain text, that is the statement or a message that can be read, no, na mabasa na to. That is excerpted from Lord Byron's poem, She Walks in Beauty. And there's also what we call ciphertext, that is the message after it has been written in code. This is the one that we cannot read. Okay? So ang tawag na to ana ciphertext. Okay? Take note that, no? Ciphertext after it is being written in code, and plain text before it will coded. Okay? So the ciphertext form of this plain text, she walks in beauty like the night, is this one, O DASWSO. You cannot read that one anymore. Okay? So the method of changing, no, from plain text to ciphertext is called encryption. Okay? Encryption ang tawag po natin dyan. And in this case, we are using the English alphabet arithmetic. And again, you have learned that there are 26 letters of the English alphabet. So we are now using the modulo of 26 arithmetic, no? Modulo 26 arithmetic. Why? Because we are using the English alphabet. So in this case, the equivalent of A is 1, the B is 2, so on and so forth. Numbering po lang yan. Then at Z, that is equal to 0. Again, tungod kay kanisya class, it doesn't mean that's just the number. Kung A, una magina siyang number sa English, no, alphabet. But these are all what we call the remainder. So obviously, A is 1. A is the first letter, so 1. 1 divided by 26, the remainder is 1. B is the second number, so 2 divided by 26, the remainder is 2. 25 divided by 26, the remainder is 25. Z is the 26th letter of the English alphabet, so 26 divided by 26, the remainder is 0. So that's why we assign Z as 0. That is based on the remainder. Again, take note, the answer is the remainder. If the encrypting code is to shift its letter of the plain text message aim positions, then the corresponding letter in the ciphertext message, no, the ciphertext message is okay. I think we have only 10 minutes, no? Okay, in this case, ako na lang sang i-stop, then I will give you another link, ha? Kay baka dili na ko mahumandayon within 10 minutes.
Yes, sir.
Okay, okay, okay. Mag-usap ako. Naraya kita pakai klase. Wala. Pwede yung klase. Ano naman? Kaya sa mga pabasa mo dito. Pabasa. Read. Yan masuk. Mula kan just Okay, shall we continue, ha? Gamay na lang. Okay, can you hear my voice? Okay lang?
Yes, sir.
Yes, sir.
Okay, okay. So let us continue on this slide. So if the encrypting code is to shift its letter of the plain text message M positions, then the corresponding letter in the ciphertext message is given by these congruence equations. C is congruent to the quantity P plus M modulo 26, where P is the numerical equivalent of the plaintext letter and C is the numerical equivalent of the ciphertext letter. The letter Z is coded as 0 because 26 is congruent to 0 modulo 26. 26 divided by 26 is equal to the remainder is 0. So each letter in the Lord Byron's poem was shifted 22 positions. So that would be our M, no? To the right, to the right. So to code the plain text letter S in the word she, we use the congruence. We use this formula, no? We use this formula to find for the ciphertext equivalent of the given uh, plain text, say letter S. So to do that, C is congruent to the quantity P plus M modulo 26. P is 19. Why? Because letter S, ang yang number, no? For letter S is 19, no? S 19. So that's why 19. Then the M shifted 22 positions. That would be your M. So 19 plus 22 is 41. Then you divide that to 26. Okay? 41 divided by 26. So what is 41 divided by 26? That is equal to 15, no? The remainder. Uh, 15, 20, 41 divided by 26, that is equal to, the quotient is 1. 1 times 26 is 26. So 41 minus 26 is equal to 15. Somehow, class, kung the value of this is more than the modulo 26, modulus 26, you just subtract, na? 41 minus 26, that's equal to 15. Mas dali para sa inyo, na? So in that case, the 15 letter, again, you go back to that given table earlier. So ang ika-15 is letter O. So in that case, ang S, once it will now be the uh, coded, no? So the ciphertext letter equivalent of that is letter O. Okay? So the same manner for H, for E, okay, until you decode all of those letters. So once plain text has been converted to ciphertext, there must be a method by which the person receiving the message can return the message to plain text. Okay, so obviously once i-convert nimo plain text to ciphertext, so naapoy that can be also way the other way around, that you can also convert from ciphertext to plain text. So we call that the cyclical code. The congruence is using this formula, no? So P is congruent to C plus N modulo 26, where P and C are defined as before, no? This is the ciphertext letter, this is the plain text letter, and N is just simply 26 minus M, okay? The N here is 26 minus M. Why 26? Because there are 26 letters of the English alphabet minus how many shifted positions? So that would be your N. In order for you to return, no? Para mabasa ni mo balik from ciphertext to plain text. Okay? So the letter O in ciphertext is decoded below using the congruence, no? Using this formula. So you have P is congruent to C plus N modulo 26. Our C is 15 because letter O is the number, no? For that is 15. Then plus 4, that is 26, minus, of course, shifted 22, no? Position. So Our M is 22, so 26 minus 22, you have equal to 4. That would be our N. So 15 plus 4 is 19, modulo 26, and again, tungod kay ang 19 is less than the modulus, so automatically mo nata ang remainder, no? So that would be our P. So the 19th letter is S, thus O is decoded as S. Okay? So tungod kang ika-19, kung tao ni mo diri sa table is letter S. So ang ciphertext letter nga O will be on S will be letter O, no? The ciphertext equivalent of S is O. Once plain text has been converted, sorry. So in this case, you have 15 plus 4, 19. So the 19th letter is S. The O is decoded as S. So atong O ganina, pagbalik na to adto sa plain text, that is equivalent to letter S. So yung Mr. So sa una ko pagkabalo sir nga, mobalik to sa dito. So you will be using this formula. Dapat kabalo ka sa M. And that is usually given in the problem. Okay? Any questions for decoding and encoding from
Sir,
plain text? Yeah.
nganong na po ng N, sir?
Tungod kay 26 minus, ang M ganina sa previous example is 22. So, 26 minus 22 is equal to 4. Muna imong
So,
N.
constant na nung po, sir?
In this example, that could be served as a number of your N. But it varies in different problems, depending on what would be your M. Karang 26 mo na constant na gina siya. N is equal to 26 until na gina 26. Dili lang mag-vary sa M. Okay? Okay. So let us have example 13. Write messages using cyclical coding. Use the cyclical alphabetic encrypting code that shifts each letter 11 positions to, okay, so itong 11, that would be your M. Okay? So M is equal to 11 in that problem. So given na ang M, you code this one, Catherine the Great, when you say code something into a ciphertext form, dili mabasa. Pag yung decode, decode, it means dili man siya mabasa, no? So when you decode, dapat imong ma-convert into readable statement. So pag decode gani, ang hint ana decode. Na pag decode mo, di gyapon mo mabasa, so wrong ang imong answer. Ana na siya kasimple. Ang code, be sure gyud kay no need man ni siya nga dili man ni dapat mabasa pag code nimo ani. Pero be sure nga sakto ay imong gibuhat. Pero nakahin kung mag-decode ka. Nakahin tungod kay once you will decode a given ciphertext, dapat mabasa siya. Kay mo convert man siya balik into plain text. So na nakahintan, once mag-decode ka, dapat mabasa nimo. Pero pag decode nimo, di gapon nimo mabasa, then you provide the wrong answer. Okay? So let us do that example, ha? So for letter A code, that means you have to convert this plain text to ciphertext mo ng code. So the encrypting congruence, so you will be using this formula. C is congruent to P plus 11. Given maning M ganina, no? 11 modulo 26. Replacing P by the numerical equivalent of each letter of plain text and determine C. Kaning P, depende kung sa nga letter, no? For letter C, so ang P ana 3 gyud. Okay, kung taawon nimo balik diri man kamo tanaw balik o ana, di ba ang C diri has an equivalent numerical equivalent of 3. So muna siya. So muna nga ang P nimo imo ang pulihan og 3 kay letter C man imo mang i-code ang C into ciphertext from plain text to ciphertext. So substitutean nimo 3 plus 11 is 14. And again, that is less than the modulus 26. So, understood, ang imong remainder is 14. So, kaning 14, imong tang-aw na po dito sa table kung kinsa dito ang ika-14. Okay? Letter that has a numerical equivalent of 14. So, when you look at the table, ang equivalent ana niya is letter N. Okay? So, muna ang C will be converted now to N or code C as N. The same process for A, T, H, E, R, I, N, E. Okay? So pareha na tanan. For letter A, ang yang P is 1. So 1 plus 11 is 12. 12 modulo 26, the remainder is 12. So you could A as L. Kaya ang L is the 12 letter, or ang yang numerical equivalent is 12. Then for T, T is 20. Ang yang P, so 20 plus 11 is 31. 31 modulus 26. Pilay bungkig sa 26. Ang 31 is, no, 31 is, sorry, 31 divided by 26. Pila ang 31 divided by 26? Walang sayop ni. 31 daw ba? 31 divided by 26, no? 31 divided by 1. 1 ta. Okay, sayop na sa class. Ang answer ana is 5, not 14. Okay? So that's why you code T as E, no? Because ang E has an Hello, can you hear me?
Yes, sir.
Hello, sir.
Okay. Then let us decode na po, no, for letter B. So ang hint is pag mag-decode ka, dapat mabasa nimo after you decode that code. Okay? So decode TGLY ESP EPCC TMWP. Because as given earlier, M is 11, so your N is 26 minus 11 is equal to 15. 26 minus 11 is equal to 15. To the ciphertext po ito, is decoded by using the congruence, no? Using this congruence, P is equivalent to C plus N. So, ang N ni mo diri is 15 man. So, imo na nang butak pulian o 15 modulo 26. So, 40, so P is congruent to 20, that is your C, kay ang T is the 20th equivalent number, ang equivalent ana niya, plus the N is 15 modulo 26. So 35 modulo 26 pulay bungkig, so 9. So then pangitaon na po nimo dito kung kinsa tong ika-9th letter, and the 9th letter is I. So decode T as I. Then for letter G, 7, ang iyang C, ciphertext equivalent ana, plus 15, that is 22 modulo 26, and 22 is less than 26. So that's why the remainder is 22. Then you decode G as V. The 22nd letter is V. No? So on and so forth. So when you decode TGLY, so on and so forth, the plain text of this ciphertext is Ivan the Terrible. Diba? Nabasa na. So kung nakita nimo nga ang decode ani is Ivan the Terrible, nabasa gini mo, then you got the correct answer. Any questions? For example, 13? Okay lang? We still have 2 slides left. Okay lang? No problem?
Yes, sir.
No problem, sir.
Okay. Example 14 and example 15. The last one is exercises. You can just submit that one tomorrow. Huh? Okay. Example 14. Encode a message. So when we say encode a message, that means you will convert plain text to ciphertext. Readable to non-readable message. Okay? So use the congruence. C is equivalent to 5P plus 2 modulo 26, no? To encode the message, laser printer. Okay, so the encrypting congruence is this one. Muna yung encrypting congruence. Given na siya ha, ang inyong buhaton ani igyo ra niyo i-plug in or i-substitute, no? Whatever the value of P times 5 plus 2 divide 26, whatever the remainder, then you have to locate that on the table. Again, take note, the answer is the remainder. Replace P by the numerical equivalent, no, of each letter from the table and determine C. So the results for laser lang ang gikuha niya, ang printer wala na. Kaya understood naman once makuha, makasabot mo sa laser, then automatically you will understood how to find the decode letters for printer. Okay, for letter L, C is congruent to 5 times letter L is ang yung equivalent ana is 12, numerical equivalent. So 12 times 5 is 60 plus 2, that's why you have 62. 62 divided by 26, the remainder is 10. So you locate again the numerical equivalent of the letter that has this numerical equivalent of 10, and that is letter J. So you code L as J. Pulihanin mo si L o J, letter J. Then A, that is C, is congruent to 5 times P. The numerical equivalent of A is 1. So 5 times 1 is 5 plus 2, that is 7. So 7 modulo 26, that is the remainder is 7. And the seventh letter is letter G. So you code A as G, so on and so forth. So ang lesser, ang yang coded letters are J, G, S, A, N. Okay? So dili na siya mabasa. So ang lesser printer, once you coded that is in the form of ciphertext, so that can be now have this form, no? G, J, G, San, D, N, U, T, X, A, N. Okay? So that is example 14. And the last example, you decode a message. In this case, we will apply the idea of multiplicative inverse. Why? Because it will not coincide directly on the given congruence equation. So for example, you are going to decode, no? Decode the message ACXUT CXRT. So kung mag-decode gani ka, o sabot pasabot ana, that means from ciphertext to plain text. So dapat kung i-decode nimo ni siya at the end, it must be readable. But the problem is the given congruence equation is solving for C, solving for the ciphertext. So once you decode, you are really finding for P, for the plain text. But in this case, it doesn't coincide on the problem that you have to decode the message. So what you need to do is, given these congruent equations, you have to transform algebraically solving for P, no? Solving for P. And that can be done algebraically and with the idea of multiplicative inverse. So first, before we'll do the decoding, we have to solve the congruence equations for P. So we'll only focus on this one. C is congruent to or equal to 3P plus 5. And you transpose 5 to the left side. So you have C minus 5 is equal to 3P. And again, in order for you to eliminate 3 or a factor of 1 here, para P na lang mabilin, the usual arithmetic that we have is you multiply both sides by the inverse of the numerical coefficient of P. That is 1/3. Para mahimong P na lang ni dire. But that cannot be done in modular arithmetic. Because here, we need to find a number, okay, that if you multiply that to 3, you divide it by 26, and if the remainder is 1, then that P, that number is the inverse of 3. So how to do that? So again, we will use the idea of multiplicative inverse. So you multiply 3 by a number. So in this case, 9. So 9 times 3 is 27. 27 divided by 26, if you will do that one manually there, if you have your paper and ball pen, that remainder is 1. So kay ang remainder kay 1 man, after you multiply 3 by 9, you divide that by the modulus, and the remainder is 1, then that simply means that 9 is the inverse, the multiplicative inverse of 3. So in that case, you multiply both sides, you multiply this by 9. So, ang atong idea, instead nga 9 times 3 is 27, no. 9 times 3 here is equal to 1. Okay? So, that's why your P, just retain P here, and 3 is not anymore present. Okay? Then, here na kay 9. Siyempre, no? Nadiri ang 9. So, you have now 9 of the quantity C minus P modulo, then you will now insert modulo 26. So, this is now the formula, the decoding formula in order for you to read this ciphertext ACXUT CXRT into readable statement, okay, or form rather. So in this case, Using this congruence, we will show the details for decoding ACXUT, CXRT. That would be your part na, ha? Okay, so A, so 9, given yan, no? 9 times, okay, what is the ciphertext equivalent of A? That is 1. Okay, 1 minus 5 is negative 4. Negative 4 times 9, that is negative 36. Negative 36 divided by 26 cannot be because that is a negative number. So what you need to do is you just add 26 until you will get a whole number less than the modulus. So negative 36 plus 26 is negative 10. Negative 10 plus 26 is positive 16. That's why you have positive 16 here. Okay? So you decode A as P. Why? Because the 16 letter is letter P. Okay? Then for letter C, 9 times your C, the numerical equivalent of letter C is 3. So 3 minus 5 is negative 2 times 9, you have negative 18. At again, the difference is negative. So just add plus 26. So negative 18 plus 26, that is equal to positive 8. And that is the number because that is a whole number less than the modulus. So that is what is the 8th letter? 8th letter is letter H. No? The 8th letter is letter H. Then X. Then 9 times X is the 24th number. So 24 minus 1 is 19. 19 times 9 is 171. 171 divided by 26, that is having a remainder equal to 15. Then you decode X as O because O is the 15th letter in the English alphabet, no? Or has a numerical equivalent of 15. Then for U, so 9 times U is 21, has a numerical equivalent of 21. So 21 minus 5, that is 16. 16 times 9 is 144. Okay? So 144 divided by 26, it has a remainder equal to 14. Then you decode U as N. No? You decode U as N. Then 40, you have here 9 times. Okay, what is the equivalent number of T? That is 20. So 20 minus 5 is 15. 15 times 9 is 135. 135 modulo 26, it has a remainder of 5. And the fifth letter is letter E. So, ang ACXUT is phone na siya. So, mabasa na, di ba? So, ang ACXUT, CXRT pala is decode as or the message is phone home. So, readable na siya. Okay? Phone home. Any questions? For example, 15? Kailang? Hello?
Yes po, sir.
Okay, so if none, this would be your another assignment, no? Exercise number 2 po ito. You submit this one tomorrow. You can take a screenshot. Picture na lang nyo diha. And you submit this one tomorrow, ha? Ano na lang siya? You submit this one on Wednesday. Wednesday ni siya nga
Okay,
part.
sir.
Wednesday ni
Yes,
siya. Then, kani siya nga part, kaning usa diri nga exercise, you submit this one tomorrow. Okay, mo ni ang Monday, tomorrow before 12, kay mas sayon naman ni siya. Then, katong usa would be on Wednesday. Okay?
Yes, sir.
Okay.
Yes, sir.
For attendance today, no? So, you can review a little bit of my presentation for 10 minutes. Then, after 10 minutes, I'll share you the link. I'll upload the link for our short quiz this morning. Okay? For just 30 minutes. Or will be closed after 1 hour na lang so that you have enough time. Okay? I think that's all. So, di na lang ako mag-check of attendance. Dito na lang sa